So, mathematical patterns, we're going to have sequences. This chapter, vocab is going to be incredibly important. Today we are going to focus on sequences of numbers, which are just lists of numbers, such as 2, 4, 6, 8, 10. Okay? They're lists of numbers where there is some sort of formula we can write that illustrates for us how to get each number in the sequence. Okay, notation is going to be important. We usually use the letter A, but we want to represent all of the numbers in the sequence with the same variable, A, so we need to distinguish between them. In this sequence, we're going to have A1 is 2, A2 is 4, A3 is 6, so on and so forth. So we've got this notation. You can read this as just the first term of the sequence, the second term of the sequence, the third term of the sequence, so on and so forth. Okay, this is just the page from your textbook that explains what I just went over. What is a sequence? How do we note sequences? Okay, the main addition here is you'll notice over here we've introduced the variable n, the n minus 1 term, the nth term, and the n plus 1 term. So if we're focused on a term like right here, let's say this is the 10th term, an is 10, is the 10th term, then an minus 1 would be the 9th term, and an plus 1 would be the 11th term. Okay? So the notation is new, but there's nothing particularly tricky about it. It's just what it is, but it is new, so just make sure you're working with it. You're going to have to get used to it. Then here, we have what is called an explicit formula. So they have this sequence, 2, 4, 6, 8, 10. The nth term is twice the value of n. So an explicit formula, we want to write a formula for the nth term of a sequence. And the term here is going to be given by 2 times n. And you can see from the table up here, the first term then is 2 times 1 is 2. Second term is 2 times 2, which is 4. Third term is 2 times 3, which is 6. So on and so forth. So this is the explicit formula for the sequence. Explicit meaning that this side of the equation just has the n involved. That's what explicit means. Now the vocab is important because instead of explicit, you could be asked for a recursive formula. Okay? And we are going to write the recursive formula for the same sequence, 2, 4, 6, 8, 10. And the recursive formula is going to be an equals an minus 1 plus 2. It's called recursive because to find the nth term of a sequence, you have to know what the n minus 1 term was. Explicit formula is better because in this case it's better. In the explicit formula, if I want to know the 10th term of the sequence, I just plug in 10 here, and what's the 10th term? It's 20. Right? That's how the explicit formula works. We would just say, what's the 10th term of the sequence? 2 times 10, which is 20. Easy peasy. Lemon squeezy. With a recursive formula, now we need to know about recursive formulas because there are some very important sequences that can only be represented by a recursive formula. It's just in this particular example, it's less helpful because if I tried to find the 10th term of this sequence, all the recursive formula tells me is that it's the 9th term of the sequence plus 2, which is only helpful if I know what the 9th term of the sequence is, right? The explicit formula, I don't need to know what the ninth term is. The recursive formula, I absolutely have to know what the ninth term is. And that's kind of the difference between an explicit formula and a recursive formula, is the explicit formula's expression will be based solely on n, whereas the recursive formula is going to be based on a term before it or multiple terms before it, and n could come up as well. Okay? An example of another recursive formula that could show up would be, we'll go 1, 2, 6, 24, 120. What is the pattern? The pattern is we're going times 2, times 3, times 4, times 5. Okay? The recursive formula for this expression, for this sequence, the nth term is given by n times the n minus 1 term. Right? So, with a recursive formula also, don't want to box that one in yet, if you're given a recursive formula like this, you also have to provide what is the first term. In this case, it's 1. Because this formula means nothing unless we know where we start. So here is the recursive formula. So for example, the second term is 2 times 1, which is 2. The third term is 3 times 2, which is 6. You're always plugging in n, and so if I'm finding the third term here, n is 3. So it's 3 times a 3 minus 1, which is the second term, which right here we said was 2. So as I said yesterday, this chapter is easier than the previous chapters, but it is also definitely something that is only going to make sense if you're doing the homework and if you're spending the time with it. All right, these ideas are not that complicated, but they are the type of thing you need to spend some time with to really fully iron out all the wrinkles. A sequence has an explicit formula, an is n squared minus 10. What is the term a8 in the sequence? So what is the 8th term of the sequence? We're searching for a8. Hopefully we all realize all you have to do, n is 8. So this is 8 squared minus 10, which is 54. So that is the 8th term of the sequence. So to write a recursive definition, we just have to state that the first term is 4. Then we want an expression for the nth term. What is that going to be here? So in this one, seeing the pattern is kind of tricky, but for each term in the sequence, for example, if we go from 4 to 14, it's 3 times 4 plus 2. Then 3 times 14 plus 2. Then 3 times 44 plus 2. So the recursive sequence, you state that the first term is 4, and then you say that the nth term is given by 3 times the term right before it, an minus 1, plus 2. What is an explicit formula for the sequence? So again, I cannot stress enough, make sure you know if they're asking for an explicit formula or a recursive formula. They are two different setups. So here, we want an explicit formula, meaning we're going to have an equals some expression that involves just an n. That's what we want. What expression could we have that involves just an n that gives us 1, negative 1, 1, negative 1, 1, blah, 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 blah. Shush. When you have signs that are alternating, like we have here, positive to negative, back and forth, you should understand that it's going to be a negative 1 raised to some power. And in this case, that power is going to be n plus 1. The reason that we know it's going to be n plus 1 as opposed to just n is because we need the first term, we know the first term is positive 1. So if it were negative 1 to the first, that's negative 1. But if we throw on a plus 1, that's going to be positive 1. So our explicit formula is right here, negative 1 to the n plus 1 power. In this case, that negative 1 has to be in parentheses because of order of operations. This is an incredibly important trick to remember in case you ever get sequences that maybe look like this. Okay? Because it's basically going to be, this is part of your formula, and then you take care of the 2, 4, 6, 8 separately. So this is, right here, very important trick to understand about sequences. Because if you have sequences with alternating signs, something like this is going to happen. So we have an online auction. The price for an item begins high and falls over time until someone purchases the item. If an item begins at $100, so the first term is 100, and decreases by 25% every 5 minutes, what is the price after a half hour? So if it's changing every 5 minutes, after a half an hour, how many times has it changed? We are looking for the 7th term. It changes over half an hour. If it changes every 5 minutes, it changes 6 times. But the first term was where we started, right? So if we start at 100 and then change 6 times, we're at the 7th term in our sequence. So we want to figure out what the 7th term is. What is a formula for this sequence? It is the term right before it multiplied by 0.75. However much you have, you're going to lose 25% of it. You just have to remember that in equations like this, if you lose 25%, it's better to write the equation in terms of what do you have left. And if you lose 25%, what percent do you have left? 75. So every term in the sequence is obtained by multiplying the previous term by 75%. So what is the price after a half hour round to the nearest cent? It should be that the 7th term is 17.80. Okay. Here. To do a situation like this, do 100 times 0.75. That's the first change. So we need 5 more. Do times 0.75. That's 2. And then at this point, just push enter. So that's 3, 4, 5, 6. 17.80.